Welcome to EDU World Space.
This question, we have to find the torque required to hold stationary and the steady state speed. First, we can use the basic equation of the moment of the momentum, and we have that for no rotation. We have that the T shaft is the integral or the area of R cross Vxyz rho Vxyz dA, or that is 2 del of integral from R1 to R0 of R V rho V dr, and that will be rho V square del times R0 square minus R1 square, where V is the exit velocity with respect to the CV, and we have that V is Q in over 2 rho R0 minus Ri, and that will be 2.4 meter per second from the given data. And then we have that the T shaft is rho Q in over 2 del R O minus Ri square del Ro square minus Ri square. So we have that T shaft to be rho Q in square over 4 del times R0 plus Ri R0 minus Ri, and you have for given data the T shaft will be 1.26 Newton meter. And then for the steady state speed, for the steady state, the speed equation becomes minus the integral of R cross 2 omega cross Vxyz rho dV equals integral of R cross Vxyz rho Vxyz dA. And so the volume integral term here, this term must be evaluated for the CV. So the velocity in the CV vary with R, and this variation can be found from mass conservation. And for the infinite CV and length dr, you have that the Q plus dq plus V del dr minus Q equal to 0. That leaves dq equal minus V del dr. So QR will be minus V del R plus some constant, and at inlet R equals Ri, so Q is Qi, that is Q in over 2. So Q will be Qi plus V del Ri minus R, that is Q in over 2 plus Q in over 2 rho 2 del R0 minus Ri del Ri minus R. So Q will be Q in over 2 R0 minus R divided by R0 minus Ri. And we can find that the water speed is Q over A, and that is Q in over 2A times R0 minus R divided by R0 minus Ri. And so the term of the integral R cross 2 omega cos 2xyz rho dv, it will be 4 rho A omega integral from Ri to Ro times R Vr dr, where Vr is here, and then we'll have that it will be rho Q in W omega cos Ro to the power 3 plus Ri square times 2Ri minus 3R0 divided by 3R0 minus Ri. So finally, go back to integral of R cross Vxyz rho Vxyz dA, which is rho V square del R0 square minus Ri square. And then you have that this term is equals to this term. Okay, and then we can solve for the omega, where omega will be 3R0 minus Ri V square del R0 square minus Ri square divided by Q in R0 to the power 3 plus Ri square 2Ri minus 3R0. And for the given data, it will be 120 RPM. So that is the answer.